So today's lab activity has something to do with water and rocks. And I know what you might be thinking is, what does water have to do with rocks? Well, let's summarize what we've learned already. We know that when it rains, water falls to the ground, and it can do one of two things. It can run across the surface, which is called runoff, and we will get to that later. But we also know that water also goes into the ground in a process known as infiltration. Now think about what this ground is made out of down here. It's not all dirt. You know that down there somewhere, no matter where you are, the ground is made up of rock. So we just said we know water goes into the ground. The ground is made up of rock. Ergo, there must be water inside of rocks. Now, this is something that's really hard for us to see because we're not down here. We're not swimming around in the water that's in rocks. So what we're going to do in this activity is prove that water does go inside of rocks. What you're going to do is you're going to grab some samples of rock. L stands for limestone. G stands for granite. S stands for sandstone. This guy here, this real flat gray looking piece, is called slate, and it doesn't have the letter S on there because I didn't want to get it confused with sandstone. So you have to realize that this is slate, and it is written on the container that you get this out of. Also going to have some lava rock. And finally, we're going to have a man-made type of rock. We're going to have concrete, which is basically what concrete is a man-made rock. The first thing you need to do with all of these samples is determine what their mass is without any water in them. All of these rocks here are dry. There is no water in any one of them because they're not underground. They haven't been rained on. So we can take their mass now, and we know that this is what the rock weighs, or what its mass is, with absolutely no water in it. So how do we determine the mass of anything? This is a triple beam balance, and this is used to determine the mass of an object. Some of you might not have used these for a while, so just a quick refresher course. It has 3 bars with 3 different counterweights on there. One for the hundreds, one for the tens, and one for the whole gram. The first thing you need to do is make sure that it balances where this little line matches up with this little line. Now, it won't do this on this presentation because I'm holding the balance sideways. What you can do is you can twist this little knob back here, play with it until the balance gets to be even. And then we know it'll give us a nice, accurate measurement. So here's what we do. Pick any one of the samples of the rock and place it on the balance. Then you're going to move this across to 100 grams, and you'll see the rock must be more than 100 grams because this arm did not come down to be even yet. So let's go to 200 grams. Nope. 300 grams. This rock is still more than 300 grams. 400 grams. Now, this rock is more than 400. It's somewhere between 300 and 400. 400 is too much. I have to put this back on 300 and add some mass up here. Let's go 350. Well, it's still heavier than 350. Let's go 380. Oh, it's not 380. So we know it's somewhere in between these two. 360. 370 is too much. So we know it's between 360 and 370. Now I'm going to move this bar right here. Let's go 365. It's a little too much. So I'm going to push this back. Let's say 363. Now we're getting close to where it's going to balance. And you keep playing with these sliders until this perfectly lines up to where it was with no rock on there. One thing of note, this balance here to measure whole numbers and a decimal. So if you're 363 but not 364, if you're right there, this would be 363.5. And yes, that 1 decimal place is going to be very important for what we're doing in this activity. So make sure you record to at least 1 decimal place. Before moving on, you notice that each of these balances has a number on there. You need to write the number of the balance that you use on your lab sheet, because you have to use that same balance again when we re-record the mass of the rocks when we're done, because otherwise the balances could be different and be giving you different numbers. It's like stepping on different bathroom scales, or your home bathroom scale versus the one at the doctor's office. They're not going to measure exactly the same. Once you have carefully determined the masses of all of the rocks, obtain one of these plastic tubs and place the rocks inside. Now notice how they are oriented. We don't want to set the rock like this. We want to set it upright so that water can touch both sides of the rock, because we want to see how much water will go into these rocks. Some of these you can lean the rocks up against each other, but don't lean them up against the side, and don't lay them flat on the bottom. Now what we do is we get some water. Take a pitcher of water, and there are pitchers over on the shelf, and you're going to put water in here. Keep filling it up, keep filling it up, keep filling it up. And if the rocks tip over a little bit, you can reach your hand in there after you're done and straighten them up. Now we need to make sure that all of the rocks are covered by water. And not just barely covered, but have a little bit of extra water on the top, because we know the water is going to go into the rocks and the water level is going to go down. So if we see here, this guy's not under the water. This guy's not really under the water. So I get some more and pour some more water in there. And fill it up to where each sample is definitely under the water and has a little bit of extra water on the top. Now after you have done this, carefully take your bucket and place it on the counter around the room. And we're going to let these sit for a couple days so the rocks have a chance to soak up as much water as possible. Then we're going to come back to these at a later date, and we're going to pull the rocks out, and then we're going to mass them again and see how much water went into each one of the different rocks. You need to make sure you know which bucket of rocks is yours. Each one of these buckets is going to have a number written on the side. You need to write that number on your lab sheet so that you can tell which bucket of rocks is yours versus somebody else's. We'll let these sit for about 3 days, and then we'll take them out, measure their mass again, and see how much more do they weigh now. And that will tell us how much water went into each one of these different samples of rocks.